Welcome to this explainer. Today, we're diving into one of the most thrilling, serendipitous discoveries in recent deep space observation. We're going to explore how a routine scientific mission, looking at something relatively close to home, accidentally uncovered an ancient, hidden secret lurking in the profound depths of the universe. It's a story of literal cosmic proportions, and it's all about a tiny, incredibly old galaxy named Bedin I.
So, what actually happens when the Hubble Space Telescope accidentally photobombs its own image? It's like the ultimate astronomical detective story. You see, when astronomers point something as powerful as Hubble at the night sky, they usually know exactly what they're looking for. But what happens when the universe decides to throw a curveball? What happens when a completely unknown galaxy just photobombs an observation meant for something else entirely? Well, this is exactly how a simple, focused mission turned into a massive discovery that forces us to rethink what might be hiding in the dark corners of our universe.
Section 1. A serendipitous cosmic discovery. To understand this cosmic photobomb, we really have to look at the original mission. Astronomers were using Hubble to study white dwarfs, the cooling remnants of dead stars, inside a relatively close globular cluster called NGC 6752, or Caldwell 93. And because they were looking so deeply into the dark, pushing Hubble to its absolute limits with optical observations reaching incredibly faint magnitudes of around V30, they stumbled onto something they absolutely weren't looking for. Way out in the deep background, far beyond the stars of Caldwell 93, they noticed this faint, unresolved smudge of light that simply didn't belong to the cluster. Section 2. Hiding behind Caldwell 93. See all those incredibly bright, glaring stars? Those belong to the foreground cluster Caldwell 93. But if you look closely at the edges, specifically where those green and magenta ellipses are, you'll spot something else. The green ellipse marks the full extent of our hidden galaxy, Bedin I. And the magenta denotes its half-light radius, basically where half of its total light is emitted. It is tucked, far, far away, completely dwarfed and washed out by the glare of the foreground stars. It's perfectly positioned right on the edge of the field of view. It's literally a dwarf spherical galaxy hiding in plain sight behind stellar glare. Section 3. Profiling Bedin I. Okay, so here's the number from the data that just completely blows my mind. 28.38 million. Bedin I is a staggering 28.38 million light-years away from us. Just think about that for a second. These astronomers were studying a star cluster inside our own Milky Way galaxy, and they somehow ended up photographing a completely separate galaxy nearly 30 million light-years into the deep background. The sheer depth of field required to make this accidental discovery is just mind-boggling. So what exactly is this thing? Taxonomically, Bedin I is classified as a dwarf spheroidal galaxy, and it's located out in the Pavo constellation. That basically means it's a small, relatively featureless galaxy that lacks the dramatic, sweeping spiral arms of something like our Milky Way. And just how small is it? Well, it's roughly 20% the size of the Large Magellanic Cloud, measuring only about 840 by 340 parsecs. Discovered by Luigi Bedin and his team in September 2018, the data confirms we are looking at an extremely distant, tiny, and very isolated stellar island. Section 4. The 13-billion-year-old fossil. To figure out the history and the age of this newly discovered galaxy, astronomers really had to act like forensic scientists. They use a color magnitude diagram, or CMD, which acts as a sort of cosmic fingerprint. By plotting the color of the stars against their brightness, they can map out stellar evolution. And what's absolutely fascinating here is the red line in the data. That is an incredibly narrow red giant branch. For astronomers, this striking narrow grouping is proof that the galaxy is ancient, around 13 billion years old, and that it hasn't actually had a new generation of stars in a very, very long time. Let's break that down just a bit further. In astronomy, anything heavier than hydrogen or helium is basically considered a metal. When stars die, they seed their galaxies with these heavy metals, so newer stars are considered metal-rich. But by translating the data from that narrow red giant branch, astronomers confirmed Bedin I has an iron-to-hydrogen ratio of about -1.3. That means it's a highly, highly metal-poor stellar population. These stars are severely lacking in heavy elements, which confirms they formed at the very dawn of the universe. This timeline right here highlights exactly why astronomers are calling Bedin I a living fossil. Around 13 billion years ago, its stellar population formed in what appears to be a single massive burst. Then, over 10 billion years ago, that star formation just completely ended, and from that moment until the present day, absolutely zero star formation has occurred. None. It has literally been frozen in time, sitting out in the dark, virtually unchanged since the early days of the cosmos. Section 5. A peculiar cosmic isolation.
This completely dead-end evolutionary history leads us to a really fascinating puzzle. You see, a typical dwarf galaxy usually has a pretty complex star formation history. It creates a generation of stars, those stars eventually die, they create heavy metals, and a new generation is born. But Bedin I doesn't do this. Because it's so chemically uniform with no new heavy metals, its evolution behaves much more like a simple, isolated globular cluster than a fully fledged dwarf galaxy. It just completely blurs the lines of galactic classification.
So, why is it like this? Well, its strange chemistry points to extreme isolation. But here's the twist. Despite being so incredibly lonely, the data suggest it might actually be a distant satellite of another galaxy called NGC 6744. Now, NGC 6744 is a massive spiral galaxy, roughly 9.15 million parsecs away, and it's often referred to as the Milky Way's twin. Given Bedin I's distance of roughly 8.7 million parsecs, it sits right in the neighborhood to be a very distant, very lonely, ancient moon-like satellite orbiting this massive spiral galaxy. I want to leave you with this final thought to really spark your curiosity. Bedin I is 28.38 million light-years away. It's 13 billion years old, and it was found completely by accident, just because we stared at a patch of sky long enough. If a living fossil galaxy can hide in plain sight right behind a local star cluster, what else is out there? What other ancient secrets are just waiting to be accidentally photobombed by our telescopes, especially as we look forward to next-generation instruments like the WF First High Latitude Survey? The universe is vast, and clearly, it still has so many secrets lurking just behind the glare of the stars we already know. Thank you for joining me on this explainer. Keep looking up.